right, class, welcome to statistics. Over this first section, we're going to learn about the different types of studies that can be conducted, most importantly, what statistics is, different types of data, and how we can represent that data. So, what is statistics? When asked what statistics are, most people will say something along the lines of averages, charts, data, information you collect. And while yes, these are all concepts found in statistics, statistics is the collection of procedures or methods for planning experiments, obtaining data, organizing, interpreting the data, and finally drawing conclusions based on the data. So statistics is the science of the collection, analysis, interpretation, and presentation of data. We can also say that statistics are the data, which is like numbers or other pieces of information we can use to describe something. For people, it could be age, weight, eye color. And we see statistics all the time. We see it on the news, television, internet, and we collect statistics about a lot of stuff. 2020, the United States is actually a census year. We're going to talk about what a census is later. But that means they're going around and talking to every single person, every single American to gather information. And that'll tell them something about our country as a whole. So we collect statistics about the population. Right now, with us all social distancing, there's a lot of statistics being collected on health, sports, finance, education, things like that. So how does statistics work? So the first thing I want to talk about is what is the goal of statistical research? So the goal is to gain specific information about a population being studied. And the population in a statistical study is the complete set of people or things being studied. So we could say the population of Fontbonne University. We could say the population of the state of Missouri. These are different populations. So because the population is the complete set of elements being studied, right? The population could be high school students graduating in May. It could be all SAT scores by high school students this year, or all cards produced by General Motors during a specified time frame. So it doesn't just have to be people. And that's something I want us to keep in mind. So for the following situation, community describe the population being studied and identify some of the population parameters, so some of the information about the population that would be of interest. So let's say you work for Farmers Insurance and you've been asked to determine the average amount paid to accident victims in cars without side impact airbags. So our population being studied is going to be those who've been in a car accident without side impact airbags. Now, what would some of the parameters of this population be interested? I know we're asked to study the amount paid to the victims, but some other things we might want to know about these population is the age, right? Older drivers tend to be in less car accidents than younger drivers. We might want to know what car they owned. We might want to know how old their car was. So there's lots of different information we can collect about this population. So the population is what we want to study when we're coming up with a statistical experiment or observation. We have to define our population. A census is a special type of study where we collect data from every member of a population. However, that can be expensive and sometimes not feasible. So if we wanted to study, for instance, all college students, we really couldn't study all college students, right? There's millions and millions of us. The population is just way too big. So what we need to do is take a sample. So sampling is when we take a portion of a larger population. So let's say if we wanted to study college students, we'd pick 5 students from every university, or we would just survey one university. That would be taking a sample. And there are many different ways to take a sample, and we will be going over those. So, like I said, a sample is a subcollection, subset, or part of the population. So, for instance, a sample of each of the above populations could be students graduating from St. Louis City Schools in May 2000, the SAT scores earned by twins and only studying twins in New York City, and then if we wanted to look specifically at the Buicks that were produced in January of 2000. So the sample is usually way smaller than the population, right? The sample needs to be of a good size. We're going to talk about how to determine our sample size later on in this course, but we want to make sure it's smaller than our population, and that way it's more easy to study. So a parameter is a numerical characteristic of the entire population, okay? A sample statistic is a numerical characteristic of a sample. So, for example, 49.6% of the world's population is female. Would our class be a good sample? Well, I don't know yet because I don't know who's in my class before I'm recording this, but take a look, right? I bet we don't have exactly 49.6% women. So one thing you might want to check is how far off are we? Are we 60% women? Are we 80% women? I know in most of the statistics classes I teach, they tend to be about 90% women. A main concern of statistics is how accurately a statistic estimates a parameter, right? We want to study a sample so we can find out some information about that and use that to make an assumption about the population parameter. This is one of the main goals of statistics. In order to make sure we can take our sample statistic and push it to our population parameter, it needs to be a good estimate of our population parameter. So we can do that by picking a representative sample. This just means we need a good sample, okay? We wouldn't want to study all women. We want to study all men, right? We need our sample to be representative of the population within we're working. So, for example, if we were studying students, we wouldn't want to select only women or freshmen, right? Because that sample would not be representative. Not all college students are women or freshmen. One way to pick a sample is to pick members randomly from the population. So let's say we wanted to determine the mean height of all the students at our school. Which is more likely to be a representative sample of this study? The men's basketball team or the students in your class? Probably the students in your class, right? Because the men's basketball team, they're going to be really tall, right? Very tall compared to the average student. So our stats class would be a more representative sample. Now, a statistical study can suffer from bias if it's designed or its conduct tends to favor certain results. So we would be introducing bias if we had decided to study the basketball students in order to figure out the mean height of our school. That would be bias. It would favor showing that our university has students who are taller on average. Now, an example is that the Nielsen Media Research Company earns money by charging television stations and networks for its services. So what the Nielsen Company does is TV channels such as NBC pay them to provide ratings for its television shows. So how many people are actually watching them? What do people think about these shows? Now, why do we think that NBC doesn't simply do its own ratings instead of paying somebody else to do them? Well, of course, NBC wants to have really good ratings, right? That means they can charge more for advertising and things like that. And so they might be able to skew their ratings, and that would introduce bias. So let's talk about collecting sample data. So there are a few different sampling methods we're going to go over, and this is how we're going to pick a sample that is representative. So the first one is simple random sampling. That means that every possible sample of a particular size has a chance of being selected. Okay? So that means if we were taking a sample, say just the people in our class, we would randomly draw people's names out of a hat. That way we all have the same chance of being selected. So let's look at an example. You want to conduct an opinion poll in which the population is all residents in a town. Could you choose a simple random sample by randomly selecting names from local property tax records? I mean, we could. That's a good idea. But how would this introduce bias? Well, let's think about it. I live in my town, but I don't own a house. Do you own a house? Probably not. So this means our study would be biased only towards those who own property. The next sampling method I want to talk about is systematic sampling. So this is a type of sampling in which we use a system such as choosing every 50th member of a population. So you could go in the phone book, if phone books were still a thing, and you could pick like every 50th person in the phone book and have them be included in your study. So let's take a look. So let's say we're conducting a survey of students in a co-ed dormitory in which males are assigned to odd number rooms and females are assigned to even number rooms. Could we obtain a representative sample if we chose every 10th room? No, we couldn't. Why? Because if we chose every 10th room, we would only get females who are in the even number rooms. We'd need to choose an odd number, like say every 9th room, because then we'd first go to the 9th room, then the 18th, then the 27th, then the 36th, and so on, right? So it goes odd, even, odd, even. So that would be a more representative sample. The next type of sample is convenience sample. So this is a sample that's used for convenience rather than a more sophisticated procedure. So like let's say my studies, I use primarily convenience sampling, but it's with a purpose because I'm studying a very small population. I'm studying students who are adults over 25. And that can be hard to find because there aren't that many of them. So I will conveniently go out and find those students who I know. This is really common in educational research, or if you're researching a very tiny population, that's something to keep in mind. So let's say a supermarket wants to decide whether to carry a new brand of salsa. So it offers free taste at a stand in the store only around lunchtime and asks people what they think. Is the sample likely to be representative of the population of all shoppers? Who shops at lunchtime? Maybe people who are just trying to pick up lunch. Most people actually go to the grocery store in the evening because they're trying to prep for dinner. So I don't think that having them at lunchtime would really be super representative. The next type of sampling method I want to talk about is cluster sampling. So cluster sampling involves the selection of all members in randomly selected groups or clusters. Let me break this down. So let's say we clustered our professors by department, okay, and number each department, and then we only select a few departments. So we could have the math department, we could have the English department, we could have biology, we could have chemistry, we could have art, we could have music, okay, biochem, art, music, computer science, okay. So let's say we broke our faculty up by department and then we only chose 4. What if we only randomly chose math, bio, computer science, and chemistry? Okay, this would introduce bias, right? Warning is we're only hearing 4 voices. In this case, we're only hearing from those in the sciences, right? We're leaving art and music and English completely out of the conversation. So that could definitely introduce bias, especially if we were trying to determine where funding should go, or who should get the newest building, or how many scholarships should we give out for what. This would have a big effect. The next example is stratified. This is a little bit better at not introducing bias, but you have to be careful. So stratified sampling involves randomly selecting members from each stratum. So in this case, we'd break up our departments, right? We had art, music, chemistry, bio, English, math, computer science. Man, there's a lot of subjects you can study, which is great. So now what we would do is we'd stratify each group by professors in their department, okay? And then we could use a random sample to select a proportionate number of professors from each department. For example, we could take 1/10 or 1/3 of the professors in each department. One thing we need to be careful about, though, is that we don't want to pick a fixed number. Because if we did pick 2 members from each department, because each department may not be the same size, I know the math department is definitely a lot bigger than the computer science department in my case. If we did this, our sample would not be characteristic of our population, as all departments are not the same size. So let's say the U.S. Labor Department surveys 60,000 households each month to compile its unemployment report. To select these households, the department first groups cities and counties into about 2,000 geographic areas, and then they randomly select households in this survey to households to survey within these specific geographic areas. So how is this an example of stratified sampling? Okay, so watch while I try and draw America. There's some water here, I'm sure of it. Then we got Hawaii. Alaska's all by itself. This is actually not bad. I'm kind of proud of myself. Okay, so how does this work? What they do is they divide the country into 2,000 geographic areas. I'm not drawing 2,000, but you're going to get the idea. So we break the country up into this nice little plaid mess. Then we pick a few people from every single geographic area. Why is it important that we, these people are in the water. Why is it important that we do that? Well, because some areas, like more rural areas of the United States, have lower unemployment rate, have lower unemployment rates because they have less people. And California and New York tend to have higher unemployment rates because they have more people. So this is a good example of stratified sampling. And the strata are these geographic regions. And I just explained why stratified sampling was important. See, I'm ahead of myself. I answer my own questions. So, for example, which of these is stratified and which of these is cluster? So this is cluster and this is stratified. And this was the best kind of image I could find of it. I want you to know that there should really only be 2 or 3 of each strata selected that way. It's proportionate. Cluster. So here's a summary of all the sampling methods. There are 5 different sampling methods. You're going to want to make sure you know how to tell these apart and identify how a sample was found. So what type of sample is this? We're picking every 3 people. This is systematic. How about this? Probably not the best thing to yell out your window, but this is definitely convenience sampling, right? You're sampling whoever's convenient. This would be a good way to conduct a survey now because we're all staying at home, chilling out. What type of sample is this? We divided our county up into the electoral precincts, and then we just picked 3. That would be stratified, which may or may not give us a... Nope, sorry. This would be cluster. Stratified would be if we took a couple people from each district. And remember, this can introduce bias depending upon how different the demographics are by election precinct in this county. Here we picked 2 from each group. This is stratified.